Welcome everybody to Research Boot Camp. Today I'm pleased to introduce our speaker, Dr. Jefferson Frisbee. And first I just want to give him credit for most of this bio that I'm about to offer to you. Okay. After a remarkably unimpressive academic performance as an undergraduate student, because there were better things to do, Jeff completed his PhD in biophysics and physiology from the University of Guelph in Canada. Following up on that, he completed a postdoctoral fellowships, or punishments, however you look at it, in cardiovascular bioengineering at the University of Washington and microvascular physiology at the Medical College of Wisconsin. He began his first faculty appointment in 2000 in the Department of Physiology at the Medical College of Wisconsin, and then in fall of 2004 he made the move to West Virginia University, where he is now the director of the Center for Cardiovascular and Respiratory Sciences and a professor in the Department of Physiology and Pharmacology. Dr. Frisbee has published over 95 journal articles, has been funded by the National Institutes of Health, and is currently funded by the American Heart Association. And of relevance to today's seminar, Dr. Frisbee is entering his 6th year as editor-in-chief of the journal Microcirculation, serves as a member of the scientific advisory group for Wiley Publishers. He also serves an associate editor for 4 other journals and is an editorial board member of an additional 5. Dr. Frisbee's here today to discuss his experiences and advice regarding publication of your scientific manuscript. So thank you, Dr. Frisbee.
Well, thank you, Julie, for giving me the opportunity to come here and speak to you today. The actual full title of the talk was supposed to be Publishing Your Scientific Manuscript, Tools of the Trade. There are no tools to doing this, so I decided to take that part out. Really, there are no special things. It's not trying to learn how to do a Western or do some sort of vessel cannulation or some other complicated procedure. The ability to publish your work regularly, routinely, and with a high success rate really comes more from just not making mistakes. Cover your bases, do the things you need to do correctly, keep your eyes and ears open, and it actually becomes fairly routine. So, what I'm going to discuss today, just some basic topics. I'd like to discuss publication of your work from the perspective of the author. We'll discuss the quality and the presentation of your work, where you're sending it, and you have to give some thought to who's actually reviewing your work. Don't just send to a journal because, boy, it sure would be great to publish in that journal. Think about who's actually on their reviewer pool. We'll get to that a little bit later. I'd also like to speak about the perspective of the editor and the associate editor. Some journals are different. In some journals, the editor makes final decisions. That's the way it is for my journal. Others, it's the associate editor that makes final decisions. The editor is there mostly for interaction with the publisher. So just because you know the editor or you're buddies with the editor doesn't really matter if they're not part of the actual decision-making process. I'd like to discuss the Ben Hogan model, which we'll get to for those of you that may not know who Ben Hogan is, and what we're looking for as editors or associate editors, both the good and the bad. And then lastly, I'd like to finish up with what are some of your experiences, questions, concerns. If you have things that are bothering you, things that have plagued you in the past, that's a good chance to throw them out there because I'm sure they bother other people too. So first, from the author's perspective, the question you have to ask yourself, you have to have your hypothesis. Do not go into a publication saying, wouldn't it be cool if? Wouldn't it be neat if? I'd really be loved to find out if. No. That's a guaranteed way to get your paper rejected before you even started. Okay? Have a hypothesis, narrow it down so it's actually a defined hypothesis. Doesn't matter whether this is basic science, clinical, or population. If you can't narrow it into a one-sentence hypothesis, the reviewers are not going to pay attention. They have better things to do than to read your diffuse work. So, is your hypothesis timely? Is it significant? Is this something people care about now? Okay? If I was to put together a manuscript on muscle energetics and how much heat is generated per muscle contraction, that would have been fantastic in the 1960s. It's going to be hard to find a place to publish that now. People just don't care. They want to know, what is current? What are the current state of affairs in your relative disciplines? And is your hypothesis something people are going to care about? Or is this going to be trivia? Is this something that people are just, it's fine. We'll just flip right past that. Is it significant? Can you clearly state it? If it takes you 7 sentences to get your hypothesis statement out, you've already been rejected. No one will read the next page. They'll just stop, send it back to the editor. This is unreadable. and goodbye. So you have to get your hypothesis clear. You have to get it so that there's no misunderstanding of what you're testing. If you leave things open to the perspective of the reviewers, frequently they're not your friends. They'll probably interpret something incorrectly, and then they're not testing their hypothesis. It opens up a whole can of worms. You've got to be specific and state it clearly. Can it be rigorously tested? We get this one a lot. Whatever your hypothesis statement is, you have to be able to test it rigorously. You cannot just describe it roughly, do a bunch of experiments sort of around the target, never hoping to hit it. People are going to want to see you test that hypothesis. They're going to want to know that it's actually in there. This is from my bioengineering postdoctoral mentor, who's both one of the nicest and nastiest guys I've ever met. He actually used to have lab meetings on weekends because he didn't want to give up those 2 days of just kicking the hell out of us. Is your hypothesis quantitative, or is it at least semi-quantitative? Anything that did not have a numerical answer to it, he didn't consider a hypothesis. And he was the editor-in-chief of the Annals of Biomedical Engineering for years. If it did not have a quantitatively evaluated yes or no answer, he would reject it on those grounds alone. So the extent to which you can make your hypothesis quantitative, do it. Don't just say, we think this will change. We think that will change. We think there'll be a difference here. Not good enough. There's a huge percentage of the reviewer population that will reject you for that reason alone. When you write your manuscript, have you thoroughly tested your hypothesis, or have you just kind of, tangentially skimmed the surface? Test it. Do the hard test. Even because sometimes it's going to come back negative, and that's scary, and then your whole process, your whole project is down the toilet. But you've got to test your hypothesis. Have you designed your experiments and analyses to go beyond? You can, and I'll spend a little bit more time talking about this before, one of the things that's most disappointing when you review manuscripts, whether as a reviewer or as an editor, is you see people test their hypotheses, design their experiments to just barely clear the bar. Provide the most superficial possible answer to their hypothesis and give them no other insight. And it just leaves a bad taste in your mouth. You get to the ends of someone's results page and you're just, bleh. You're waiting for that next thing and it's not there. You're going to read the whole discussion and you're going to get angry again because there's nothing for them to talk about. It's really easy to check the reject box. Okay, push your experiments, push your analyses. If you think multiple databases are required to answer a public health question, get multiple databases. Don't just use the one that's easily available. Context. People talk about knowing the literature, knowing your background, and having this encyclopedic knowledge of the literature. It's really not as important as a lot of people like to make it out to be. Most of the literature is, let's just say, not accurate. Okay? That's just being blunt. I'm not going to sugarcoat it. It's just not accurate. There's things that aren't reproducible, things that you can never do yourself, things that people have overinterpreted, underinterpreted, misinterpreted. So this encyclopedic knowledge of the literature that some people have is really of limited value. It's not the best way to spend your time. Know enough of the literature to determine the context of your manuscript. So what's currently going on in the literature? What are the current questions people are asking in your academic discipline? Okay. Does this question fit? Is this question totally out of left field? Is this something that's going to change people's opinions of how science is done, change their approaches, change their mindset? Or is it something that's just going to, kind of go unnoticed? And then when you get to your results, how well do those fit with the existing literature? Are you just doing the same thing that's been done 1,000 times before? I hope not. No one wants to publish that. Or have you really changed the game a little bit? Is there something significant in what you're doing that says this body of literature over here is no longer, it just doesn't fit with this data, these data? Okay? It's an important question to ask yourself. How well does it fit with the rest of the world? And it's okay if it doesn't. Actually, sometimes it's better if it doesn't. It makes for more interesting paper. Your data, like I said, do not trip over the bar. Do not think of the fewest possible experiments. the most superficial possible analysis of the data. What's the smallest number, what can we just show is statistically significant with that number of patients, then move on? Don't do it. Make your data set robust. Give the reviewer confidence in what you're doing. Okay? If you can afford to do 8, you have the time to do 8, basic science obviously, do 8. Don't just do 5 because you can get away with 5. Do 8. Don't listen to the IACUC all the time. Don't do it. Okay? This is for your science. They're regulatory. They go live somewhere else. Your data is your story. No one wants to read to the end of a weak, boring story. It goes nowhere and has already been done to death. Wow, we see a lot of this. People who have done the same experiment again and again. People have had careers on this. They've published basically the same paper 80 times. I don't know how they do this. It's a fantastic accomplishment, really. But this work has already been done. Your data says something about you. Okay? When I look at Amy Hunter, for those that don't know her, that's Amy Hunter. When I look at PhD student epidemiology, I want to think, this is Amy Hunter's paper. I may or may not know Amy Hunter personally, but I know her reputation. Her reputation is that she tells an interesting story, different perspectives, multi-scale resolution, things like this. When I read Amy's paper, I'm already 80% the way to accepting it, just because it's hers and she has a background of actually telling an interesting story. She gives me something more to go on than just, here's a series of Western blots and then, so what? She actually will give me more than that. And it makes, you're already most of the way there. If you get to the point where your reputation alone is that you are a sufficiently talented and thorough scientist, you'll win a lot of battles just with that alone. Push to the limits of interpretability. This one is variable. Some people over-push the limits of interpretability. But really take your data as far as you can. I was always taught as a graduate student, normalize every variable you have to every other variable and normalize all of those to time and to mass. And then just see what relationships come out, because you never know what might fall out of it. Just keep playing with it, analyzing it, trying it again and again and again. And just keep going with it. Maybe you find a relationship between blood pressure and myogenic activation that you didn't know was there. That hopefully you do. If you work in my lab, you better know it's there. But keep pushing it. Okay? It's the worst feeling in the world to see your trainees come to your office with a stack of data that they haven't pushed. Here's the raw data. I don't give a crap about the raw data. I know what the raw data looks like. Do something with it. Impress me with your ability. Same thing, impress the reviewers with your ability. Okay? Figure out how to push things. If you don't know how to do it, get help. There's other people who can help you with this. It also helps lead the reviewers that they may not naturally go. I can give you a little personal experience on this. We spent years publishing data that turned out to be not as informative as I hoped it would have been. As it turns out, none of the reviewers picked up on it either. It was only when we took a completely different approach to data analysis that we actually started to see something. And we dragged the reviewers along with us. And now the reviewers love it. I got to go spend 2 weeks in Europe last summer, all expenses paid by European universities. It was awesome. Just so I could talk about this new thing. And we've only got, and that's all they want to talk about, Oxford, King's College, all of them. They thought this was great. And it was only because we just kept pushing it. We just tried to keep seeing something novel and innovative. Clarity. Do not hide things. Not all reviewers are smart, but an awful lot of them are. Okay? They will find you. Okay? If you're hiding things in your data, if you don't want to show something or you're keeping something out, they'll find it. And then you have a very awkward email you have to write to the editor. It's not awkward for me to read. I kind of giggle at it, but you don't want to have to do that. Okay? Don't hide something. If you have an observation you cannot explain, doesn't fit with the rest of what you're doing, hey, that happens to everybody. Welcome to science. But don't hide it. People will find you. Presentation. Well, you'd be surprised how often this first one gets ignored. Please write well. Please write clearly. If you can't do it, please pay someone to do it for you. People won't read it. They'll get to the end of the first page, quietly close the manuscript, write no on the cover, send it back. You could have the most elegant, you could invent warp drive in your manuscript. No one's touching it if they can't get through it. Present your data thoroughly and clearly. If you can't, get help. CTSI, you guys provide help for this, right? Nodding. Okay, good. So, yeah, get help with it. I don't know how to do that plot. I don't know what that means. I don't know why I would do a three-dimensional plot. How do I do that? Well, it'll show you something. Figure out how to do it. Push it. Take the reviewers by the hand, because most reviewers are going to do this at 10 o'clock at night after they've had a long day and at work and their spouse has been yelling at them and their kids are poorly behaved. Those are your reviewers. You need to present your data clearly and help them, because otherwise they won't do it. Reviewers are inherently lazy. Again, present it thoroughly, don't hide it. Introduce new points, but do not belabor them. This is called speculation. I probably have this in there a little bit further as well. Here is a unique and special observation. Ed makes a great observation. Ed Pistilli, right there. I'd point at you, but that'd be bad. Ed makes a great observation about muscle tension development, muscle fatigue, skeletal muscle myocyte function. New. No one's ever seen it before. Highlight that. This is something wonderful that I have done, Ed Pistilli, but that's it. You don't have to belabor it. People will know. Just highlight, you did it, this is something cool, reviewers please focus on this, focus on the implications, focus on what matters, and now we will continue. If you belabor it, they'll start hacking you. This becomes excessively speculative, excessively verbose, and nobody wants to hear it. So they'll just stop. Okay? Some speculation is good and important. Excessive is a cheap and easy target for reviewers. You know how on NIH studies section, reviewers will respond, oh, this work seems really good, but it's a little descriptive and incremental. That's the review of a coward and someone who should be taken out back and beaten. Okay. Reviewers will do the same thing on manuscripts. It seems very speculative. They should cut this back a lot. It's an easy one. Don't give them the chance to make that comment. Don't let them do it. Focus your discussions. Focus your arguments on the topics at hand. Going on for 8 pages impresses nobody. It angers almost everybody. Where do I send it? This would be your manuscript. The first thing you need to do is take a look in the mirror. I know everybody wants to say I've published in Science and Nature and whatever your respective specialty journal of interest is. Not going to do it, most people. I hate to be a glass of cold water in your face. Not everyone's going to get into Science and Nature. You need to look at your manuscript and ruthlessly and objectively assess the content. Is there really something here? Really? Or has this been done half a dozen times in the literature? Okay. Is this the latest, newest, greatest clinical procedure I can possibly think of for heart replacement? If that's the case, you could probably go to a pretty high-impact journal. If not, it just wastes time to submit to circulation just to get it rejected. Why would you bother? Understand the mission and the scope of individual journals. Ask yourself, why does this journal exist? Why does the Journal of Pediatrics exist? I'm not a pediatrician, but it exists for a reason. Okay. Does it publish all of pediatric research? Certain kinds of pediatric research? Are there places that are specifically intense in that journal, other ones that are not? Okay. Know why the journal exists, and is it an appropriate place to submit your work? So the question I would ask pretty much any graduate student interested in cardiovascular physiology, what's the difference between circulation, circulation research, and AJP, heart, and circ? Those are probably the top 3 journals in the field for cardiovascular. Publication in any one of those should make you smile. Does anybody know? Circulation is the top journal of the American Heart Association for clinical research. If you're doing human subject research or population-based research, and you want to publish in an American Heart Association journal, that's where you send it. Circulation research, on the other hand, is the top basic science journal. If you've done something incredibly sexy with a mouse, scientifically, or a rat. You've done something really unique, something high-end, something that's probably not reproducible. You'll publish it in you'll try to get it published in Circulation Research. Okay, those are the key journals people go to for that kind of work. AJP Heart and Circulation Physiology is more integrative. Okay, so circulation people, circulation research, myopia, however that's pronounced. AJP Heart and Circ stands in the middle. It's a place where you have something more integrated. You want to see how whole organs function. What happens in the heart when you have heart failure in an animal model? You know, unless you're going to go way into the genomic profiling and proteomic expressions, circulation research is probably not going to be that interested. Okay? So know your journal. Know where you're going with things. Otherwise, you're just going to stack up rejection notices. And that makes everybody feel bad. This is important where you send it because it will impact the reviewers for your paper. Okay? Circulation is just eyeball deep in clinicians, public health experts, things like that on their editorial board. Go to their webpage. Look, they list them all right there. Why would you send something on a mouse to those people? They're not going to know what they're talking about. And vice versa for Circ Research. They have their editorial board, they have their reviewers, but they all specialize in the scope of that journal. Okay? My journal, Microcirculation, I have a broad spectrum of reviewers. I have nobody who works on blood coagulation. Nobody. We're not publishing that. So, but yet I get 3 or 4 of them a month. Here's our paper on fibrin. I don't care. Administratively reject. Who is reviewing it? Now, this is an interesting topic, and it caused Dr. Manier to flinch a little bit when I told him I was going to discuss it. But, sorry, Fred. Reviewer pools have changed dramatically in recent years. They're not what they used to be. And that's important for people. You need to keep that in mind. With declining funding levels, it doesn't matter if it's AHA, NIH, they're all down across the board. Professional service is no longer valued so much. This is not a secret. Everybody knows this. Okay. So there's an awful lot of good reviewers out there that now say, this is not worth 5 minutes of my time to give to this journal where I will get nothing on the tenure and promotion ladder for it. So they don't do it. That makes my life hard as an editor. It makes your life hard as an author. We've also had 30 years of NIH beating everyone to death, with reductionism and specialization being rewarded, and integration and meaningful context being punished, as there's that word again, descriptive. So there's now 2 generations of scientists out there that love to study incredibly narrowly defined projects in eye-watering detail. If you're not studying their project, do you really want them reviewing your work? Do they have any appreciation for what you're trying to do? Probably not. We'll routinely get reviews back from people who have literally no idea what they're talking about. And then what do I do as an editor? I got to go back and start again, find new reviewers. Okay? This is actually, in my personal, this is just editorializing, this is my opinion, this is the biggest problem that NIH has created itself in the last 30 years. They've forced people into these pigeonholes if they're going to be successful, and now they're stuck. The incentive to become an associate editor, it's an interesting experience. It's kind of fun. You know, you get to see the other side of how things work. You get a really good handle on what other people are doing around the world. And it is educational. I have learned multiple things that I would not have seen had I not been in my positions. Like if you're a really good reviewer, your name will get around at light speed, and you'll be avalanched by review requests. As an assistant professor, you know, I would say, you know, try to do as many as you can legitimately do without having them compromise your productivity. Same thing as an associate professor. As a senior professor, you know, it's kind of up to your own decision. I routinely ignore reviewer requests from a certain family of journals just because they're not worth the effort it takes to open the email. Like, I will not review for some of the, I don't want to name the publisher, but I think we're probably all thinking of the same one. We turn over our editorial board every 4 years. And every 4 years I solicit nominations from all of my associate editors. I don't know the whole spectrum of microvascular research. That would be kind of pathetic in its own way. But I have these experts. This person knows angiogenesis. This person knows inflammatory cascades. This person knows... I want 4 people from your area that are established senior investigators. And then I want 4 more that are the hot young assistant professors. That's written in their I wrote that into their instructions. So I can get constant turnover, get more people, new people coming into the process. That's how. If you want to be on the editorial board of a journal, get to know the people in that journal, publish in that journal, and just keep working. Eventually it'll happen. This has fundamentally changed, so the 30 years of reductionism and specialization has fundamentally changed our reviewer pool. So when you go online to submit your manuscript, you'll see little boxes in there that say requested reviewers, requested associate editors, and also non-requested, or ones you'd like to see excluded. Those boxes are there for a reason. Use them. Don't just say, oh, I don't know, I think anybody should be able to review my work. Okay, that's stupid. Okay. Figure out who you want to review it and put their names in there. People are inherently lazy. They'll just say, oh, fine, I'll send it to these people. Ding, ding, ding. And that can really benefit you. Just going in there with a blank slate, you have no idea who the editor is going to pick. Myopic reviewers. We get them. They're out there. They exist. Some editors-in-chief and some associate editors will actually say that review is offensively bad, and I cannot send it out with my journal's letterhead on it. So they'll overrule them. Not all of them. Some of them, it's just a cookie cutter. The review comes in, one says accept without revision, one says reject with extreme prejudice. They'll just reject it. They won't even bother reading it. I attend the editorial dinners. Ugh, it's horrible. Yep. Some are really good, some are not. And that's just something you have to, you learn trial and error. What do I do? So you submitted your manuscript, some number between 2 and 1,000 weeks go by, and you get an editorial decision. What do you do with that? Well, if it comes back as accept, smile, feel good about yourself, move on to the next one. I had lunch with Greg Hand, the Dean of Public Health, the other day, and he refers to it as this feeds into his rule of 3. We took the rule of 3 simply as being routine for everybody. You want to have one manuscript that you're working on, one manuscript that's in review, and one manuscript that's in post-production at all times. If you want a successful research career, that's your target. If you're not there, you're not doing something right. Okay? So he refers to it as the rule of 3. So when you get an accept back, that's great. Get on to the next one. Don't roll around in it and feel good. Move on to the next one. Accept pending minor revisions. That's the next level down on our editorial feel-good meter. Sink the putt. Sink it now. Don't wait. Don't go home for Christmas. Don't do anything. If you have minor revisions, do the damn minor revisions and get it back in and get the thing out and off your plate. Okay? Extremely frustrating as an editor where you have an accept with minor revision and it's like, please change this comma to a semicolon, and it takes them 6 weeks to get it back in. Okay? It just holds up everything. So when you get that, and they're clear about it, it'll say accept pending minor revisions, favorable reviews, yada, yada, yada. Sync it, and then see above. Feel good about yourself, move on to the next one. Next level down, major revisions required. 85% of manuscripts get this across the academic spectrum. Read them carefully and understand them. If you don't understand them, send the editor or the associate editor an email. Don't just blindly feel your way around hoping to maybe hit the target. That wastes time and money and effort. Contact them. They will clarify it for you. They will tell you what they want. Even if it's, we want you to go away, they will tell you. When you get a list back of comments required, answer them all of them, every one of them, all of them, every damn one of them. Don't miss any. Answer them. Okay, if you miss them, the reviewer will think you don't care what the reviewer had to say, then they'll read your paper again, and they'll punch a hole in it. Okay. Some may need more data and analyses, more experiments, another data set, something. Some just text changes. Argue your way around it. Okay. Understand the difference. That may go back to contacting the editor-in-chief. Okay. Do I really have to do another $10,000 worth of mice? No, you're fine. Just talk your way around it. We're good. And they'll tell you. It's in their interest. They need to fill page charges. Okay, so they'll tell you what they want. They won't lie to you. Be respectful at all times. Wow. Another one like as in, write using the King's or Queen's English, whatever the proper term is. Be respectful of your reviewers. Don't write back, this reviewer is an abject moron. Don't do that. We get this all the time. People fighting with their reviewers like anyone's going to pay attention and listen. They won't. They'll just reject you. Be respectful. Yes, this is excellent, great, insightful point. Even if it's, violates Newton's laws of physics, this is a great point. We have absolutely pushed the envelope on this one. This is in our future plans just as soon as we get that, great. Be respectful. Do not be discourteous to your reviewers. I don't care how much it hurts. Reject. We don't reject things outright all that often. Some journals will do more than others. I don't like to reject all that often unless it's egregiously bad. I usually give people the benefit of the doubt and give them a shot. Read and understand the rejection. Again, contact the associate editor or the editor-in-chief if you require it. Learn from those comments. Okay, you're not going to get it published here. But here's half a dozen comments that you may not have thought of. But if you incorporate those into your work, you may get it accepted at the next level journal or a different one. This is all an educational process. Some reviewers will actually take a long time to say, this is why your work stinks. And, but it does help you when you hear that. Okay? It just may require you to do some more work and try somewhere else. Reject and lousy are not synonyms, unless they tell you they are, in which case you will not confuse it. Frequently we reject because of scope. I don't accept anything on coagulation. There's other areas of microvascular physiology or blood rheology that we don't publish. It never even enters into a scientific review. It's just reject. It doesn't fit the journal. Reject. It's not sufficiently novel. None of that is a review of your work. It's something else. So read the rejection letter. Don't just slam it down on the desk and go off and pout. Read it. Understand why you're being rejected. There's also reject because of ethical misconduct. That's what you really want to read. Now, I'd like to move on to my perspective as an editor-in-chief or an associate editor of a journal. That's Ben Hogan. For those of you that don't know who Ben Hogan is, he's a golfer. This is arguably the most famous picture in the history of golf, which goes back an unbelievably long time. This is the Marion Golf Club, 1950 U.S. Open. Ben Hogan was 212 yards away from the front fringe. He hit a 1-iron onto the green, sank the putt, got into a playoff round, and then he won. One of the greatest, most shining moments in the history of golf. Gives me shivers just thinking about it, because I've never hit a 1-iron quite like that. This is John van de Velde. This is 1999 British Open at Carnoustie, the 72nd hole, also the 72nd hole. John is not standing in the middle of the fairway, is he? Okay. John had a 3-stroke lead. Went in there, barfed up 3 strokes to the rest of the field by playing around in the water. He lost. The take-home message here, it's not the great shots that you do hit. It's the poor shots that you don't. And that might have been said by Ben Hogan. I don't know. It was said by somebody. Not everyone is going to hit a laser shot into the upper deck with your manuscripts. That's not how the scientific field works, ever. Most of you, me, most of all of us, it's just one base hit after another. Okay? Don't screw it up, and you'll be able to publish. Because you're not going to get we found the cure to heart failure. No, it's probably not going to happen. But we found this is important. We found that is important. Present it clearly. Present it well. Present it concisely. Interpret properly. You'll get it published. Not a problem. So what are we looking for? Is this hypothesis really significant? And the question is, and we'll read it over and say, is this hypothesis really good? Well, we think that with diabetes, there's going to be an impaired endothelial function in the vasculature. Oh, God, really? So there's only been about 100,000 papers written on that topic. So that's probably going to get rejected right out of hand. So is it an innovative hypothesis? Or is it just Me Tooism? And that's from David Sidorovsky this morning at IHOP. So they have the new raspberry white chocolate pancakes for the Christmas season. Oh, they're awesome. David had them. I had the heart-healthy omelet. So but yeah, are you actually doing something innovative? Or is this just another person showing the same damn thing? Oh, look at that. Chronic smokers have a higher incidence of lung disease. Somebody better write that down. Okay, so really, this is what we're looking for. I don't want to publish stuff no one's ever going to read. Make an impact factor, page hits, downloads, things like that matter to me as an editor. If your stuff is boring, I'm not going to publish it. Does it change the perspective? Paradigm shift. That's the word that we like to use in the ed biz. Okay, is there a paradigm shift here? If there is, I want it. I want it in my journal. Even if it's wrong and insane, I still want it because people will read it. People will cite it and download it and say, they thought this turned out to be nuts, so it's not really true, but we still saw it, and we still cited it, we still downloaded it. As an editor, that helps me. Does it add to the current body of knowledge? Yes or no? I don't know. Read it over. Is this just the same thing again and again and again? You wouldn't believe. Those of you that go to experimental biology, go to it this year and see how many thousands of posters are put up there talking about how oxygen stress makes something worse. Anything. Plate tectonics, galactic formation, who cares? It makes them worse. Like, great. We all know this. We need something more than this. That doesn't add to anything. The least publishable unit, or salami science. And I can give examples across the scientific community. As an editor, I will give one of the most egregious examples that we get. Twice a month, I get a manuscript submitted from one of the highest profile population health epidemiologist guys in the world. This is one of the most influential people out there. His work is utter crap. I can't even find people willing to review it anymore. I'll have to invite 15 people to get 2 who are dumb enough to say yes. Everybody else, no, 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 hell no, not a chance. Don't ever write me again. That's what I get. This person has hundreds and hundreds of publications. Every one of them is 1 angstrom from the other. Okay, so we're going to look at the clustering of metabolic risk factors for some poor health outcome in 13 to 15-year-old girls. I can guarantee you, 2 weeks later, I'm going to get the same paper, clustering of metabolic risk factors for that same damn poor health outcome in 15 to 16-year-old girls. Using the NHANES data set, using the briefest data set, using, it's the guy's nonstop. It's ridiculous. We're not publishing any of it. I've actually written this person personally and said, please take me off of your list. I will never publish another one of your papers again. Stop emailing me. And he does for a few weeks. I'm going to have to send him a virus or something one of these days. Maybe IT can help me with that. So when we see that, if we even get a whiff of it, we're going to downgrade your paper. If this is just another of the same shaved off, paper thin thing, we're not going to look at it. We won't. Is the methodology appropriate to the hypotheses? This goes across with experimental, analytical, spatial, temporal relevance, all of these things. If you want to test how this, if Ed wants to test how skeletal muscle myocytes contribute to integrated muscle performance in somebody running on a treadmill, Ed better have more data in that paper than just a couple of myocytes contracting in a bath in his lab. I don't care what Ed finds, it doesn't mean anything to me. There's a whole other, there's multiple levels of resolution there that have all been ignored. It could be a complete artifact what Ed's finding. I don't mean to pick on Ed too, he's a good guy, but I mean, it's just, you just don't know. So your methodology is not right for your hypotheses. So dead right away. Is the methodology excessively artificial or rigged? This is one that people like to hide. If you get caught, you're dead. Okay? Very significant investigator that I spent many years working with as a colleague was studying a certain pathway of arachidonic acid metabolism, how it contributes to organ function in certain disease states. Yet he blocked pharmacologically every possible known pathway of arachidonic acid metabolism that exists. I mean, it must have been like pouring maple syrup into the bath for all the drugs that were in there. Left only one pathway open, and then saw function, and then blocked that pathway and saw a change in function, and said, oh, look how important this is. Well, you've only left one possible pathway open. Of course it's all going to funnel down that way. Nobody else in the country can repeat his work. Yet there's hundreds of papers out there on it, flooding the literature. So it's all rigged. Don't do it. Okay? He gets away with it because of what his last name is. You probably won't. Can this be replicated? There is a piece of data going on out there that gets sent around to all of the editors. It is the number of manuscripts published in the highest impact journals, those with an impact factor of greater than 10, and how many of that percentage is actually repeatable. It is disappointingly low. People will rig their data, screw with relevance, just to get it published in a high-impact journal, knowing that you'll never be able to reproduce it. But then they can say, oh, look, I published in the Journal of Wonderfulness. Your stuff has got to be replicated. This is not something that will bite you in 6 months. This is something that will bite you in 10 years. If you go out and publish 20 papers and nobody can replicate your work, they're going to see your work come across their desk again and say, maybe not. What are we looking for? Do the data make sense? It has to pass the smell test. If you've done an N of 4 and it splits a 20% difference between two groups, to 4 decimal places, p less than 0.001, and no, I'm not buying that at all. We all know what the biological variability in systems is. Don't lie to me. I know what a vessel looks like. It's in my sleep, unfortunately. I know what the data are wrong. I know what I've had incorrect, inaccurate, fabricated data placed on my desk. I know. So I don't publish it, whether it's mine or somebody else's. Is it logically interpreted? Is it uniquely interpreted and then well explained? How's your presentation? Is that logical? Does it follow a nice path? Does figure 1, figure 2 lead you into figure 2? Figure 3 gets led into figure 4. Do your data make a nice story? Beware of results not shown, personal correspondence, and other sorts of things. Published in an abstract form, don't do that one. Okay? You say results not shown, I immediately think you're trying to hide something. And I want to know why. Are the data appropriately interpreted? Are we all reading the same paper? I love when we get a paper that shows a series of data and then you read about how they're interpreting it and it bears like no resemblance. I thought you said this variable went up. Here it's going down. What are you doing? Here it's not changing. Dead right away. Have the authors simply rewritten the results? We titled that section the results section so you can present the results. We titled that section the discussion section so you can discuss the results, not retype it out for me. I don't want to hear that, there was a 50% difference between column A and column B. So what? Why does that matter to me? Okay. Discuss your results. Don't just represent them. Have the authors gone off the deep end, respeculation? Well, we talked about that already. Have the authors attempted to integrate their results with the larger context? Yes, important. We see this. Others saw that. How does what we say matter? Why should you pay attention to us? Well, because it fills this missing gap we had over here. Highlight that. Tell the reviewers that. This is not known. What we're contributing today shows us how to know this. That's pretty much all I got. Those are the tools, such as they are. If you have questions, your experiences, your comments, what do you struggle with? So I want to leave the last chunk of this time open to give you a chance to tell me what if you have anything, what you'd like to discuss. Yes. What's my opinion about open access journals? To be totally honest with you, I don't have one. They exist. They're out there. I don't know that they're really that beneficial. I think it's blurred the line. I think it's been mostly a way of people gouging money out of other people. But, that's the way it looks like to a lot of people. I don't know that it's that beneficial. Stuff is coming out in a few months. I don't know that we can pay to have it out in 5 minutes. We can pay. I don't know that it's really that important anymore. But I don't subscribe to it myself. Yes. It will tell. So look at the journal's website. It will tell you acceptance rates. Sure. I mean, that really depends on the specific journal. So the question was, know your competition, know where they're publishing, and then you go somewhere else. So sometimes some journals absolutely have that mentality. You know, if we've already published 3 papers on sickle cell anemia, we're not going to want to see another one. So they'll just reject you on those grounds. Again, not even a scientific criticism. But other journals don't seem to mind that. And I don't know if there's a pattern out there for it. Some of them like to actually corner the market. You know, we are the journal where sickle cell anemia research gets published. So it's really variable, at least in my experience. Yes, sir. Yeah, finding the time to get your writing done. That is hard. I could try to sugarcoat it, but that is a very real issue, because it isn't just finding 2 free hours. It's finding 2 hours to effectively clear your mind, get thinking about the issues at hand, and get yourself in the right mindset to be able to actually bang out half a dozen pages. I do a lot of my writing in the evening. That's just the way life works. I do a lot of my writing from hockey rinks. I just sit in the lobby with the wireless going and just peck away while the boys out there on the ice. That's just what it is. But I personally cannot do the half hour a day. It takes me a while to get my mind going in the right context. By the time my half an hour is done, I've written 3 words and I'm done. You're right. And I realize HR. Is anybody from HR here? Boy, I sure hope not. Stay home. Don't come to work. Stay home and write. If you can carve out a day a week to stay home and write, work it out with your chair, your director, your dean, whoever you have to talk to, and figure out how to stay home and write. And cause that way you're not going to get, you can turn your cell phone off, you can do all the rest of that, and you can actually have a day, you should be able to write, once you get good at it, you should be able to write at least a draft of a paper in a day, once you get good at it. Speaking now as a center director, chair, things like that, you better show productivity at the end of that. We're not paying you to work on your golf game. So, I've got to be isolated. I have to be alone to write, and it does take time. It's hard though. I don't have a good answer. I have a mindset on this that I don't know that everybody shares. So take what I say with a grain of salt, or at least in that context. I would rather get my research disseminated regularly and routinely in good quality journals than just working to get one paper in circulation. There are others that do not agree with that philosophy. They would rather publish 1 paper every 3 years but get it in a really high impact journal. I would rather publish 3 papers a year and get them into good impact journals. I want my name out there. When people say, have you seen this latest thing from Frisbee's lab? I want them to know. It's worked out okay for me. I mean, I'm quite pleased with, I love working at WVU. It's great here. I'm quite pleased with the whole thing. That's my model. I always wanted to get something out. I did not like papers sitting on my desk collecting dust. Plus, the longer it sits on your desk, the longer you give somebody else a chance to publish it first. And that's a bad feeling. When you open up a, web page and see basically your work that's just been published by somebody else. So I try to get, that's why I like AJP's, some of the, AJP has carved out, for those of you that care about physiology, AJP has always carved out its market niche as being the repository for American physiology. That's what AJP exists for. And, I said years ago, a career publishing in AJP, I'll be quite happy. Be quite just fine with that. So it's a constrained optimization, I guess, for you stats people. Yes, ma'am.
Do you see many instances where a researcher opts not to make the major revision journal?
Sometimes. It's not. For my journal, it's probably less than 20% people do that. If I send back major revision, and I always try to tweak the reviewer comments to make them be positive. Some reviewers are just jerks. There's just no other way. There's no 2 ways around it. They're abusive and nasty and things like that in their reviews. And I go in there and take all that out. I want to encourage the authors to keep submitting and keep coming back at it. And that's as much as anything a reflection of how my career started. I got a lot of encouragement and a lot of mentorship from David Shepro, who used to be the editor-in-chief of microvascular research back in the day. And he was extremely helpful to me by treating me in that way. And so I try to treat other people in that way myself. So I try to get them to come back. I don't want them to go somewhere else. Yes? So the comment for those that may not have heard it was to use some of the up-to-date technologies like EndNote, Ref Manager, and things like that as you prepare your manuscripts and you build your own personal database of the literature. Yes, a good advice that I probably should follow more, but I don't know. I'm a throwback in some ways. Any other questions? Thank you for your time.